Hi everyone, back for the third edition here of my lesson sequence on working with surds. This time we're going to go for something a little bit more interesting. What if we had something like the square root of 27? That's nice. It's definitely a surd, but it's because 27 is not a square number. However, I could think of this as the square root of 9 by the square root of 3 because 3 times 9 is the same as 27. So we're using our multiplication rule in reverse. This time we're thinking of factors of 27. 9 and 3 are factors. Now, square root 9, that's a perfect square. Square root of 9 is 3, and I would still have root 3. So square root 27 is a surd, but it could be simplified and written as 3 times the square root of 3. That's good. Let's try another one. Let's do something a little more challenging this time. What if we had the square root of 288? Now, I would like to be able to write this as two factors. Two numbers multiply to equal 288, and importantly, I want the two numbers, one of them, to be a perfect square. Now, you might not see it straight away. A handy uh, trick that I think of is to do a prime factor decomposition or a factor tree. Now don't bother dividing by 1, 1's not a prime number anyway. So the first prime number is 2, and I can see that that would work because 2 would divide into this 144 times. Now you might know that 144 is a square number, in which case we're onto it. So we'd put the square number first, then the non-square number, and the square root of 144 is 12. 12 12s are 144 multiplied by root 2. There you have it. We've got the prime. We used a little factor tree. Didn't have to do a complete factor tree. Just the first step was enough to give us what we needed. The goal is to write these as a square number multiplied by a non-square number. And that way, our square number can simplify. Square root 288 is 12 root 2. Much easier. Square root 27 is 3 root 3. Much easier. And that's really all there is to this one. Thanks for watching.